Start with this problem right here, and you really need to follow exactly what I do, because I've been doing this for a long time and I still do it this way. Now there's some mistakes here. For example, this one, it should have t square here. That should have t square. Somehow Doc dropped it. Alright. So these two equations are the same equations actually. Alright. Only difference is they split up this delta x, right? Because delta x is equal to x final minus the x initial. If you substitute this into here and bring out the negative x to the other side of the equal sign, this is the equation you get. Alright, so it's the same thing. So we're going to calculate time using the second constant acceleration equation, which is equation number 2, and quadratic formula. So here's example number 1. Okay, an object with initial forward velocity of 15 meters per second in the positive x direction. So as soon as you read that, so initial forward velocity of positive 15. So you write it down. V initial is equal to positive 15 meters per second x hat. Is accelerating forward at positive 5 meters per second squared. Now notice the unit for meters per second squared is for acceleration. So if you know these units, it will tell you exactly what those numbers are. So acceleration now is given to us as positive 5 meters per second squared x hat. And moves forward and is displaced delta x of positive 10 meters. So it's telling us my delta x, which is change in position, happens to be positive 10 meters in the x direction. Now their question is, how much time does it take the object to cover that 10 meters? So they want to know how much time does it take. So time is question mark. Now if you notice, I have these 4 variables and 3 are known, and I'm looking for the 4th one. And look at this, 1, 2, 3, 4 variables, right? So I can probably use this equation, which is delta x is equal to vi times time plus 1/2 times a times t squared. All right. Now, I always write down the formula that I'm going to use first. Then, now we plug and chug. So delta x, we know is 10 meters. So 10, you could put positive 10 if you want to, is equal to, vi is positive 15. Again, if you want to put positive in front, you can. Times time, which we don't know, plus 1/2 times a, which is positive 5 meters per second squared, times t squared. So if you write this out in descending order, it will be 2.5 t squared plus 15t minus 10 is equal to 0. Okay? So this is your A, this is your B, and this is your C. Okay? So your A is equal to 2.5, your B is equal to 15, your C is negative 10. So now you can get your calculator out, and you turn it on, and you go to program, and hit quad, and then you hit quad again just to get your A prompt. Then you plug in 2.5, and you hit enter. Then they're asking you for B, so you hit 15, enter. Now for C, you must use this negative. That negative is this negative right here. Don't use minus. Yeah.
Can you look at error message?
Okay, hold on. Oh, really?
Yeah.
Okay. Yeah?
Why are we using for quadratic formula when the equation up at the top is not the quadratic formula?
Huh?
The equation up at the top for t is not entirely the quadratic formula, but we're using the quadratic formula.
Well, how else are you going to solve for time here?
Well, I was solving using the equation at the top.
Yeah,
It's
but
different because I have a lot of time within the square root.
okay. All right. Well, let's move on with it, and then let's see what it comes out. Okay. So minus, you hit this negative sign right here, and then 10, right? And then hit enter, and then I get two answers. I get two answers. Okay? And the answer that I get here, t is equal to either 0.606 seconds or t is equal to negative 6.61 seconds. Okay? Now, obviously, time cannot be zero. I mean, time cannot be negative. Okay? If you get negative time, either you should win a Nobel Prize or chances are you're wrong. Right? So this is the correct answer for time. All right? All right, so let me pause it here. So now let's take a look at the second problem here. The second problem here, an object moving backwards passes the position x is equal to negative 20 meters. So what does that negative 20 meters represent? Now look at this meters right here. So this x is equal to negative 20 meters is the initial position, right? Initial position x. And that happens to be negative 20 meters x hat. With speed of 30 meters per second. But that's only the speed of 30 meters per second, but it is actually moving backwards. Therefore, my initial velocity happens to be negative 30 meters per second x hat. Okay? If it is being pulled forward with an acceleration of positive 10 meters per second squared, so they're giving us the acceleration. X hat. How long does the object take, right, to pass through the position positive 70 meters? So that's x final happens to be positive 70 meters, and they're looking for how long, which is the time. All right? So half the battle is like recognizing what's given to you and writing down all the variables that you know. If you could just do this, I'll give you half the credit of whatever the problems were. So make sure you do this all the time. Then we can probably use this equation right here, right? Which is x final is equal to x initial plus vi times time plus 1/2 times a times t squared. Now you plug in chug. Your x final, 70 meters. Your x initial, negative 20, plus negative 30 times t, plus 1/2 times positive 10 times t squared. So, if you work this out in a descending order again, right, here, 0 is equal to then, this is 5t squared minus 30t, right, minus 90 is equal to 0. So this is your A. Your A is 5. This is your B, which is negative 30. And this is your C, which is negative 90. Then, again, you use your quadratic formula program. Go into program, you select quad, you hit again, and then they prompt you for A, which is 5. Enter. Negative 30, again, you hit this negative, right? Negative 30, right? And then hit enter. And then negative 90. And you enter again, and boom! You get 2 answers. Alright? Now, your T is equal to either 8.2 seconds or negative 2.2 seconds. Obviously, negative time does not work out, so this is the correct time for your answer. Are we good? All right? All right. I'm going to give you, if you were to think about the 4 equations that we have to use in the constant acceleration equation. So our equation number 1 is simply, right, VF is equal to VI plus AT. Our equation number 2 is, you could do it 2 ways, right? X final, right, is equal to X initial plus VI times time plus 1/2 A times T squared. Or is simply delta X, if you bring this to the other side, is equal to VIT plus 1/2 AT squared. So either one is, they're same things, depending on what's given to you and what you have to find. And then equation number 3 is VF squared is equal to VI squared plus 2A delta X. Now, VF and VI, they have to be positive or negative, but when you square it, they're always going to be positive. Okay, so, however, when you take a square root, you will always get plus or minus. So you have to pick which one, whether you pick the positive or you pick the negative. Okay, and then equation number 4 is simply delta X is equal to, right, VF plus VI over 2 times T. Out of these 4 equations, there are 5 unique variables if we don't separate this. Okay? That is VF, VI, A, delta X, and T. So these are the 5 unique variables, okay, that we have in these 4 equations. So, when we have let's say we have, you know, this, and this, but we have no idea about what that is. Let's say out of the 4 of these variables, we're looking for one of those 4. Then we use equation 1. Okay? And if we have, let's say, I don't know, this, and this, we use equation 2. If we don't have time, right, we only have, let's say, this. If we don't have time, and time is not, then we use equation number 3. And if we don't know the acceleration, but we know it's constant accelerated motion, then we use equation number 4. Okay. For equation number 3, when we don't have time, that doesn't mean like you use this equation when you run out of time at the end of the class. No, that's a different thing, okay? So hopefully this gives you a better picture of how we can approach these problems using these formulas, okay? What I'm gonna do tomorrow is I made these like little cheat sheets. So I'm gonna cut this little piece out for you, okay? And you can like tape this on back of your calculator, okay? And then use it when you're solving problems for homework and quizzes and tests. But if you get caught by your math teacher, I'm just gonna plead ignorance. It's like, I don't know what you're talking about. So, all right, I'll stop there for today, and hopefully you should be able to do pages 10 and 11 for your homework tonight. All right, we'll meet up tomorrow. Have a nice day.